Hello students, welcome back. Before going over to the next question, I'd like to request you to go through the playlist featuring the previous year's solved physics numerical board questions. I've shared the link of the playlist in the description box. I'm sure it will help you a lot while preparing for your exams. Please do check out all the questions and make sure that you practice all of them before going to the exam. Hello students, welcome back. Today we'll discuss about a very common problem faced by students while solving light chapter questions, and that's the use of correct sign convention. So in today's video we'll understand the analytics of it and also learn about the signs which have to be used in the ray diagrams that are given in the book. So let's start. So to understand this, we'll take the help of a little bit of mathematics over here and use a graph paper on which I have drawn a number line. You can see this is a number line. I'm sure you all know how to use a graph paper. So this is the origin O of the number line, and any distance measured to the right of O, right? So to the right of O along the positive x-axis is positive. And similarly, any distance measured to the left of the origin along the negative x-axis is negative. Similarly, any length measured along the positive y-axis is positive, and any length measured along the negative y-axis from the origin is negative. Okay, now if any object is lying over here, let's say any object is lying over here, then to measure its distance from the origin, we'll have to go towards the left from the origin, right? We'll have to go this way towards the left. So its distance will be along the negative x-axis. The value which we'll get would be negative. So here we can see here that its distance is minus 7 units. Now if you have to measure its height, we have to draw a perpendicular from this tip to the positive y-axis like this. So the height of the object would be this length, right, from the origin along the positive y-axis. So its height would be in positive. So here we can see it's 2. So the height of this object is plus 2 units. Got it? And this one is minus 7 units. Next, let's say any object is lying over here in this way. Now to measure its distance from the origin, we have to go towards the right along the positive x-axis. So its distance will be positive. So here you can see the distance of this object is positive 8 units. Now if we are to measure its height, so this is the length or the height of this object. Now to measure its height, we have to draw a line perpendicular onto the y-axis. So here you see it is coming at negative 3 or minus 3. So we can say that the height of this is negative 3 units. So I hope you are clear with this concept. Now we'll place an optical device like mirror or lens in the number line such that the center of that optical device will coincide with the origin of the number line like this. Let's say we place a concave mirror over here in this way. So the center of this concave mirror, that is the pole, will coincide with the origin. And similarly, if we use a convex mirror like this, then also its pole will coincide with the origin of the number line. Similarly, if we use a convex lens, the center of the lens, that is the optical center, will coincide with the origin of the number line. If we use a concave lens, then also its center will be coinciding with the origin of the number line. That is, they both will be at the same point. So we'll have to measure the object distance, image distance, focal length, height of the object and height of the image in accordance with the values as measured in the number line. This is rule number 1. Rule number 2 says that any distance measured along the direction of light is positive and any distance measured in a direction opposite to that of the direction of light is taken as negative. So always a source of light is kept here. Okay, the source of light is kept at the left. So light rays will always travel from left to right this way. Any distance measured to the right from the origin while going in the direction of light is taken as positive, and any distance measured to the left from the origin while going against the direction of light is taken as negative. So if I summarize it, any distance that is measured to the right of the origin or the optical center of the lens or the pole of the mirror would be positive. Any length or distance measured to the left of the origin or the pole of the mirror or the optical center of the lens is taken as negative. Similarly, if you have to measure any distance or height upward, that's along the positive y-axis, the value would be in positive, and any distance measured along the negative y-axis would be negative. So I hope you are clear with this concept. So now let's have a quick look at the points that are given in your book. So the first point says the object is always placed to the left of the mirror. This implies that the light from the object falls on the mirror from the left hand side. So if this is your number line, then this is positive x, this is negative x, this is positive y, and this is negative y. So object is always placed to the left of the mirror. So if this is the origin of this number line and here we have placed, let's say, a concave mirror, then this is the pole of the mirror. So the object is always kept. So this is the object. The object is always kept to the left of the mirror. Always you will find on this side. Whether it's a concave mirror or a convex mirror, object is always kept to the left of the pole of the mirror, such that the light from the object falls on the mirror from the left hand side. The rays of light which incidents on the mirror are from the left hand side. All distances parallel to the principal axis are measured from the pole of the mirror. Okay, so this is the object, and to measure the distance of the object, we have to go this way, that is parallel along the principal axis or in a direction parallel to the principal axis. So all distances parallel to the principal axis are measured from the pole of the mirror. So whether your object is here or your image is formed here, the distance will be measured will be parallel to the principal axis starting from the origin or the pole. So this was the second point. Now coming to the third point. All the distances measured to the right of the origin along the positive x-axis are taken as positive, while those measured to the left of the origin along the negative x-axis are taken as negative. To measure this distance, I have to go towards the right from the origin or the pole of the mirror. So this distance will always be in positive because my numbers or my values are counted along the positive x-axis. And similarly, if I have to measure any distance going to the left of the origin or the pole of the mirror or the optical center of the lens, I have to go in a direction to the left of the origin, that is along the negative x-axis. So here, since all the quantities or the values are in negative, so if I have to measure any distance in this way, the values will obviously be negative. So this side is negative. Then the fourth one is distances measured perpendicular to and above the principal axis, that's along the positive y-axis, are taken as positive. If I have to measure the height of this object, I have to draw a perpendicular to it on the y-axis. So this direction is along the positive y-axis. So the distance or the height of this object or this distance will be in positive quantity. Similarly, if we observe this value, so to measure this height, we have to draw a line along the negative y-axis. So this value is coming in negative y. So this height will be in negative quantity. Distances measured perpendicular to and below the principal axis along the negative y-axis are taken as negative. This is the fifth point. Now for lens, we follow the sign convention similar to one used by spherical mirrors. We apply the rules for signs of distances, except that for all measurements are taken from the optical center of the lens. According to the sign convention, the focal length of a convex lens is positive and that of a concave lens is negative. If this is the number line and let's say we place a convex mirror over here, the optical center is this, that's coinciding with the origin of the number line. This is positive x, positive y, negative x and negative y. So all other sign conventions remains the same except that the focal length of this lens is over here, f2, and this one is f1. So the focal length of this convex lens is positive. If we take a concave lens like this, then the focal length of this concave lens is negative, this one. So if we summarize it, focal length of a convex lens is positive and the focal length of a concave lens is negative. So now we are clear with the sign convention. Now let us understand this with the diagrams that are given in your book. So now let us understand the first case of the ray diagram using a concave mirror. That is when the object is at infinity. Okay, object is at infinity. Now you see here the object is very far away, it's at infinity. So the incoming rays are parallel to each other. So the object is situated to the left of the pole. So to measure the object distance, we have to go towards the left from the pole, right, where the object is situated. So if we have to consider with respect to the number line, we are going towards the left from the origin. So any distance which is measured to the left of the origin is negative. So our object distance will be in negative. Now the incoming rays after reflection from this concave mirror, they are incidenting at the focus, right? So this is the point where the image is formed. So here is your image and this distance is your image distance. Now to measure this distance, again we have to go towards the left from the pole. So the image distance will be negative. So I write here image distance is negative. Now focus, we all know concave mirror has a negative focus. So focus of this is negative. So this distance is also to the left of the pole. So again the focal length will be negative. Now come to the second case. The second case is when the object is kept beyond C. So object is beyond the center of curvature. Now you see here, this is AB is the object, right? And to measure the object distance from the pole, we have to go towards the left along the negative x-axis. So our U is negative over here, right? Now after the reflection takes place, the rays meet at this point and here you see our image is formed A dash B dash. So this is the point where the image is formed. So this becomes our image distance. Now to measure the image distance, again we have to go towards the left from the pole or the origin. So again, since we are going towards the left from the origin, our image distance will be negative. Now the focal length, we all know that again here is the focus. So the focal length is also negative because to measure the focal length also we have to go towards the left from the pole, right? Now comes the height of the object. You see height of the object, this is the height of the object. Now to measure the height, we have to draw a perpendicular line from the object, from the tip of the object onto the y-axis. So if I imagine this is my number line, so this distance will be my height of the object, that is along the positive y-axis. So my height of the object is positive over here. Now come to the image. See, the image is an inverted image over here, this one. Now this image is lying below the principal axis. This is the principal axis and it's lying below the principal axis. To measure its height, we have to draw a perpendicular from the tip of the image onto the negative y-axis. So this is the origin or the pole and this is the height of the image, that is along the negative y-axis, right? The height of the image in this case is negative. Now if we see the next two cases, that is the third one, that is the object is at C. You see here the object is here, so to measure the object distance we have to go towards the left from the pole. So object distance here is negative. Similarly, image is also formed at the center of curvature, and to measure the image distance also we have to go towards the left from the origin or the pole. So image distance also is negative. Now focal length of a concave mirror is always negative. Now height of the object. So height of the object is positive. Now the image is lying below the principal axis. So this is the height of the image. To measure it we have to drop a perpendicular like this. So this is your height of the image, which is along the negative y-axis. So the height of the image is negative. Now let's go to the next case where the object is between C and F. Similarly, object distance here towards the left, so U is negative. Image is formed here. Again, to measure the image distance we have to go towards the left, so image distance also is negative. Now height of the object is positive because it's lying above the principal axis, so height of the object is positive, and focal length is negative for the concave mirror, and the height of the image, because it's lying below the principal axis, the image is an inverted one, it's lying below the principal axis, so this will be its height, that's along the negative y-axis, so height of the image will be negative over here. Now let's come to the next case. The object is between C and F. So in this case you see here is our object AB, and the object distance is measured going towards the left from the pole, so object distance here would be negative. Now the image is formed at infinity, because you see here the reflected rays are parallel to each other and they meet at infinity. So the image is formed at infinity, but it is formed in front of the mirror. So to measure the image distance we have to go towards the left from the pole. So our image distance also is a negative quantity. Focal length is negative. Now height of the object. The object is lying above the principal axis, so its height will be measured along the positive y-axis in this way. So the height of the object is positive quantity, and the image which is formed is an inverted image, and the inverted image means it's lying below the principal axis. So wherever these rays meet, let's assume that these rays meet over here, let's assume. Now the image which will be formed will be like this, right? So this will be the height of the image, and it's an inverted one, so the measurement of this length would be along the negative y-axis, right? We'll have to go in the direction of the negative y-axis to measure its length. So height of the image is a negative quantity. Now the next case, that is object is in between F and P. Okay, so between the focus and the pole. Now here you see the object is at this point AB. Now the object distance is measured along the negative x-axis, that's towards the left from the pole. So our object distance is a negative quantity. Now come to the image distance. This is a special case in which the image which is formed is a virtual image. It's erect and it's formed behind the mirror. So the image which is formed over here, this will be the image distance V. Now to measure the image distance from the pole, we have to go towards the right, that is along the direction of light, along the positive x-axis. So our image distance here would be positive because we are going towards the right. Next is focal length. Focal length of a concave mirror is always negative. That's a constant for all of these. So the height of the object here is again along the positive y-axis. So height of the object is positive. And height of the image is a virtual image and it's erect and it's lying above the principal axis. So this is the height of the image. Now to measure the height, we have to drop a perpendicular from the tip of the object along the positive y-axis. So this is the height of the image, which is positive quantity. So here the height of the image will be positive. So I hope you have understood this. Now let's come to convex mirrors. So this is a case when the object is at infinity, right? So here the object is situated to the left of the convex mirror. So to measure the object distance, we have to go towards the left starting from the pole. So our object distance will be negative. Now the image is formed to the right of this mirror. You can see over here it's a virtual image and it's formed to the right. So the image distance here would be positive because to measure the image distance we have to go towards the right from the pole. And focal length of the convex mirror is positive. So here you can say this is the focus. So to measure the focal length we have to go towards the right from the pole or the origin. That's along the positive x-axis. So the focal length of the convex mirror is positive. Then come to the second case, object anywhere on the principal axis. Object is anywhere on the principal axis. Now let's say the object is here at AB. Now to measure the object distance, we are going towards the left. So U is negative. The image which is formed here A dash B dash. It's a virtual image and the image, this is the image distance. So to measure the image distance, we have to go towards the right from the pole. So the image distance will come to be positive. Now the focal length of the convex mirror is always positive. Here, so here is the focus. So to measure the focal length, we have to go towards the right. So it's always positive. Now height of the object. This is the height of the object which is lying above the principal axis. So its height would be measured along the positive y-axis. So it will be a positive quantity. So we can imagine this is our number line. Okay. And this is positive y. This is negative y. So to measure the height of this object, we have to draw a perpendicular onto the positive y-axis in the number line. So this height would be the height of the object which is positive. Now the image which is formed is virtual and it's erect and it's lying above the principal axis. So since it's lying above the principal axis, to measure the height of the image which is formed, we'll have to measure the distance along the positive y-axis again because the image is lying above the principal axis. So here the height of the image also will be positive. So I hope you are clear with the mirror. Now let's go to the lens. Now if we have a look at the ray diagrams for the convex lens, that is when the object is at infinity, to measure the object distance we have to go towards the left. So U is negative over here and image is formed to the right, that's at the focus. So V is positive. Focal length of the convex lens is always positive. So these are the values. Now when the object is beyond 2f1, the object distance is this. So U will be negative. V is formed over here. So to measure it, we have to go towards the right. So V is positive and focal length is positive for a convex lens. And now the height of the object, you see it's above the principal axis. So it's positive. The image is lying below the principal axis, which is negative. So height of the image will be negative over here. Now the third case, that's object is at 2f. So here is a 2f1. So here you see the object distance is negative, the image distance is positive. This is the image distance, this is the object distance. Then focal length is positive. Height of the object as it's lying above the principal axis, it's positive. And the image is lying below the principal axis, so height of the image is negative. Now in the next case, when the object is between two f1 and f1, the object distance, this is the object distance, u is negative, this is the image distance, so image distance is positive. Next, focal length is positive. Height of the object which is lying above the principal axis is positive. Height of the image which is lying below the principal axis, this is negative. Now the next case, object at f. So u will be negative over here because this is u, and v, the image is formed at infinity, but to measure it we have to go towards the right from the optical center, so v will be positive. F is positive. Height of the object, it's lying above the principal axis, so it's positive, and height of the image is lying below the principal axis, so it's negative. In this case, this is the object AB. To measure it, we have to go towards the left from the optical center, so object distance is negative. The image which is formed here is a virtual image and is formed on the same side as that of the object. So to measure the image distance also, we have to go towards the left only. So image distance here is negative. Now focal length is positive. It's a constant for all convex lenses. Now height of the object, it's lying above the principal axis, so it's positive, and height of the image which is lying above the principal axis again is positive. So these are the cases for the image formation using a convex lens. Next we'll understand the image formation using a concave lens. So you see here the object for this case is at infinity, so their incoming rays are parallel, so object is to the left, so object distance is a negative quantity. Now the image distance also, you see here when these rays are coming parallel, after a refraction they appear to be diverging from f1. So this is the point where the rays appear to diverge from. So here the image is formed, so this becomes your image distance. So image distance is also negative. Focal length of a concave lens is always negative. Okay. Now for the second case, the object is situated anywhere between the object is anywhere on the principal axis. Now this becomes your object distance. So object distance is negative, and here is your image. So the image distance also is a negative quantity because we are going towards the left to measure the image distance. Now the focal length is always negative. Now height of the object is this AB, which is lying above the principal axis, so it's positive. Now height of the image is an erect image, it's lying above the principal axis, it's a virtual image, so the height of the image, since it's lying above the principal axis, it will also be positive. So I hope that by now you are clear with the sign convention. Now that we have studied about the sign convention in detail, let us summarize all that through this diagram given in your book. So here MN is a mirror over here. It could be a mirror or any optical device. Then the center of the optical device coincides with the origin of the number line. A source of light is always kept on the left hand side. So the direction of light is always from left to right, this way. Now the object is always kept on the left hand side of the optical device. So here if AB is the object is always kept to the left of the optical device, and to measure that distance from the pole or the optical center, we have to travel towards the left. So this distance comes to be negative. So in order to measure any distance, if we travel towards the left from the pole or the optical center, its distance should be measured in negative quantity. Similarly, to measure any distance, if we travel from the pole or the optical center to the right, the distance is a positive quantity. Then, if any object is lying above the principal axis, then the height is measured in the upward direction and it's a positive quantity. So, any height measured upwards from the principal axis is always positive. Similarly, any height measured downwards from the principal axis is a negative quantity, whether it is in front of the mirror or the optical device or formed on the other side. This height would always be a negative quantity since it's lying below the principal axis. So if we summarize everything, any distance measured to the left from the center of the mirror or the lens is a negative quantity, and any distance measured to the right of it is a positive quantity. Any distance or height measured upwards from the principal axis is a positive quantity, and any distance or height measured downwards from the pole from the principal axis is a negative quantity. Light travels from left to right and the object is always kept on the left hand side of the optical device. So this was the summary of all the things that we have studied till now. I hope now you have a clear picture about the diagram and all your confusions would have been removed by now. So that was all from me to explain you the sign convention. So I hope you liked the video. Please give it a big thumbs up and share it with your friends, and if you are new to the channel, request you to please subscribe to it.